Okay, so this video is for students in my class that are absent for exam revision, but hopefully it might be of some use to others as well. So I've got a technique that I want to talk you through about how to tackle some exam revision. So you need access to past papers. If you have them printed out from your teacher or you're using the Hazy revision guide, you can find them electronically there. So the first technique I want you to do is take a minute to have a look through some of those exam papers and start to come up with the topics, the subtopics, if you like, of what you see. And so you're going to have to pause this video and do that task. You'll come up with things like induction, functions, polynomials, complex numbers, vectors. You'll probably come up with a list of maybe 8 to 12 subtopics that you can recognize. The goal is of doing this technique is that when you do past papers, my suggestion is that you save a couple of past papers to do as full 2-hour papers, but then the rest you break down and do them per section. So you'll identify where the induction question is in each past paper and say do all 5 of those. And so each time you're doing some exam revision and you've got, say, an hour or 2 to do some revising, you would go, okay, I'm going to tackle this topic. And then you feel like you'll know most of that topic. So pause this video and see if you can come up with the subtopic names, and then I'll put them up here, what I feel that they are, in a minute. So I'll assume you've taken some time to work through the past papers and come up with some subtopics. This is the grid that I give my classes that they're actually working on right now to sequence their exam revision. This is, again, just one technique. So this grid, the intention is across the top, you would write in the years. So for example, my class is going to leave 24 and 23 as whole papers to do. So we're looking at 22 backwards. So 2022, you would write in this top box, then 21, 20, 19, 18. Bearing in mind that the 2018 and 19 papers are 3 hours, not 2 hours. So there's more questions. So then, as you can see here, I've grouped it by different topics. I think the induction questions will be easy to identify. So again, when you've got some time to do your exam revision, you would find all of the induction questions and do them. So if you're writing 2022 in the top column here, I suppose I could write it there for you to show you what I'm talking about. Then you open up the 2022 paper and you go through it and you go, okay, so I'm looking at the first question of 22, question 1, and that would be a solids of revolution. And so I would be putting a 1 into this box here. Each question can only go in one box, but you can have more than one question in any box. So then the idea is that you identify the say 5 questions for solids of revolution through 5 exam papers, and when you're working on that, you do them together. Okay, so then I'd love you to take some time and to start looking through the 2022 paper and allocating each of the questions to a section. I'll just summarize this more. Functions and polynomials, again, they're sort of easy to spot, but one year it might be more about functions, one might be more about polynomials. The logistic and slope fields are quite easy to spot when you see that grid for having to draw a slope field. And the logistics is all about that rearranging technique. It's like a technique that you can learn, sort of almost a set of steps. So that should be easy to spot. There'll be probably two vectors questions in the exam. Don't worry too much about what I've got in brackets anytime. I think when you have to do row operations, that's quite easy to spot with the matrix planes and things. So that, again, when you're doing your exam revision, you can get lots of practice at row operations. There'll be a vector, another question, again, more about planes or proof, that whether you've got the diagrams and you have to use all your vector techniques. There'll be 2 complex numbers questions. Don't get hung up on what I've got written here. The de Moivre theorem, nth roots, Argand, draw. Drawing the Argand diagram will only be a couple of marks. So it's not like the whole question is just going to be about drawing Argand diagrams. Basically, it's about, there'll be 2 complex numbers questions. So there'll be one, quite a heavy one probably, towards the end of the paper, that might involve the de Moivre, finding those nth roots. It could be triangle inequality somewhere in there. And then the other complex number question put in the second box. There could be 3 questions all up, particularly when you get to the 3-hour papers. I find another thing that's really easy to spot is the parametric equations. So the moment you see x equals y equals, just chuck that in the parametric section here. And then I've got some spots at the end. It might depend each year. They might have another question on a few different things. So different things with functions, you know, we've got the absolute values in different places, or inverse. That sometimes might be connected to an integral or a polynomial question. And then implicit differentiation, so those related rates in terms of those sorts of worded questions that might involve some time or some water coming out of a tank, those other questions that you haven't got spots for. And you've got some blanks at the bottom as well too, if you actually prefer different wording. So I'd like you to pause again and take some time. This will take quite a few minutes to fill out this grid for each of the years, and I'll fill it in too, and we'll see if we roughly match. All right, do that. So I'm going to assume you've had some time to work through some past papers and to fill out this grid. If not, and you're just using what I've got, okay, fine. You'll gain much more out of this if you do try it yourself. Okay, so I'm just going to summarize what we've got here. We've got 5 past papers here from different years. Let's go through it one at a time. So induction. I've also written a note of what types of questions those were, in terms of if you want to try and predict what you're expecting this year. Pardon me. Okay, the functions, polynomials. Again, the functions could probably be put in a separate section as well, but this is what I've noticed. So question 3, then nothing significant in 2021 for there, or for polynomials in that sense. 2, 9 and 3. The solids of revolution, or integration by parts, that's where they are, 1, 4, 6. Now, noticing in the 2019 and 18, they're 3-hour papers, so sometimes you're going to get those questions multiple times. Then we have, moving down, the slope and logistic. Again, they're quite easy to spot. 7, 7, 10, 8 and 10, 9 and 13. Moving through the grid here, the vectors, the row operations, it's pretty easy to spot when it says the words row operations. My students are also noticing where in the paper that happens to be. For example, induction, you know, sort of around the middle of a 10-mark question paper, middle to early. Whereas the logistics, they were noticing, where are they there? You know, more that 7, 8, not 6, 7. Okay, then same for the row operations around that point. Vector proofs with planes. So my point is, as you can see, there's 2 rows of vectors. And so when you come to do your exam revision, my idea is that these 2 rows of vectors, those questions that they cover, try and do all of those questions in a revision session. And so then you feel like you're as prepared as possible for vectors. Complex numbers, as you see here, that's 2 rows as well. So if you were doing the exercise and you see for this last column here, there's 10 and then 2 and 15. It doesn't really matter where you place those numbers, if you've placed 10 and 2 in the first box and then 15 in the next one. Because when you come to do your complex numbers revision, my suggestion is to do these 2 rows of questions all at the same time. I mean, across a few hours, that sort of style. The parametric, again, easy to spot when it's x equals y equals, grouping that. And then towards the end, some of these rows are not filled in because there might just be some questions that didn't quite fit. So there we go. I hope that is of some use. While we're here, pretty much everybody that's doing specialist maths is doing or has done methods. So let me quickly show you the grid that I do for methods. If I'm just going to swap the screen here. Here we go. Hopefully that's worked. So I've got it, and I have a 2-page version here, calculus on one side, statistics on the other. And I'll just go through this quickly, how I've grouped that. First principles is easy to spot. I think there was one year in recent times there wasn't exactly a first principles question, but it was a first principles idea of it, of the limiting values, that sort of thing. Graph of f dash of x, that's what I mean, is those questions where they don't give you the equation. You might be given the derivative graph and you have to graph the function or the second derivative or something like that. So you need to know features about the max and mins and x-intercepts, that sort of stuff. Applied questions, they'll be worded questions, so they're fairly easy to spot. If there's a proof, that's often easy to spot. Integral basic, that's often maybe at the start of the exam, just crunching some numbers on that. By integral area, what I mean is you might have a graph and you've got, say, an upper function and a lower function, and you have to do the top one, subtract the bottom one. It could be a question where you need to know that you can have a negative integral, but you can't have a negative area. Or it could also be a question where, or things are below the curve, below the x-axis, and working out that sort of stuff. And again, an applied integral question, so that'll be a worded question. Statistics, some basic ones, calculating means and standard deviations. Confidence interval questions, they're pretty easy to spot. Central limit theorem, by that I mean when you have to use like the mean of the means, so you're using the distribution for the group of data as opposed to, say, that whole population. So it's taken a sample, and so then that changes the standard deviation, and so reduces the width. Then there'll be basic NCD questions or BCD. I mean, that's calculator talk for normal, cumulative, and the binomial questions. Inverse normal are easy to spot. The PDF function should be easy to spot, and then expected value type questions. So I hope that grid is of some use to you all. You're sort of welcome to reach out to me if you do need some help, but I'm sure your teachers are of some use. So I hope this video is of use to some people. Thanks for watching along.